Basically, we're talking about
This is Dave Gerold from the Twin Cities Model A
straightening
Club. Today we're going to do a video
one of the two
for
axles,
record for
and
the club's future use
we're showing
of
the
how to
setup
evaluate
that
and straighten
we're using
axles.
to do that. I'm going to switch to the second video where we're
The process of evaluating an axle is just to check to
we're
see that
showing
it's
here
straight between the
axle is straight
bosses, the
on the flat table, and then we're shining
and
a
the
light
kingpin
underneath it
boss.
to pick up
When the axle is straight,
light shining under
these
it.
surfaces
Pointing
all
out that the
lay
bosses should be
across a
resting
flat
flat on the
surface with
table,
no
and
space
the rest
below
of the
them.
axle
And
should
if
all
you
be
can see,
right against that
there
table.
is space.
So I'm
underneath
pointing
this
out that
axle
that's
is
the
bent
worst spot.
in this direction.
That's about
And if I get down here and look at it, it's actually
high
close.
at that point.
In some cases approaching 3/8 of an inch. Generally,
So we're going to be the next video. We're going to be taking this over
and then
to
there's
the
actually a
press,
section
and
right
we're
over
going
here
to be
where it
pressing
actually
the
has kind of a
button.
reverse bend.
Talking
Almost like
about
somebody ran into
where
a
I
stump.
see right now, there's a
One
kind of a
time
reverse
sharp
bend there.
and
Looks like somebody hit a
here's
stump
we
at
pulled
one
this
time.
thing out of
So it's bent
the
backwards towards the back of
ruts
the car.
in the
And then the
road
rest of
with
the
a
axle
tow
is
rope.
bent
They
forward.
just put a
It
general
almost looks like
bow
they're
to the
using
whole
toe straps
whole
or
axle,
chains or
so
whatever to pull it out
it
of
needs to be straightened for the
some
car
ruts in the
to
road.
drive properly. One other issue with this axle is we actually have a broken
We're going to show
spindle bolt.
Now we're talking here about
that
a
we do
broken
need
perch
to press out
springs
also.
bolt that we're
And,
going to
you
press
have to
out
be
of there.
careful with these. You have to be careful with these axles that you
And,
don't heat them. All your
show us this
presses,
in the
all
next
your
video.
work on these
We're
axles
going to do that.
are supposed to be done with the axle cold. So getting that bolt out could be an issue. So it takes a pretty good press. Okay, here at the press, we're going to
Over at
remove
the
that
press, we're going to set
broken
up
perch bolt
to
first.
push that bolt out. I've taken a piece, I've taken a section of a 5/8
Cut off
inch
bolt, hard
grade 8
bolt here,
bolt
move that out.
and machine the ends flat on it so that we can get on that and press on it.
And then we're gonna
That's
try to be a little safe here.
dangerous.
We're going to
We're changing
clean this
the,
up so in
we're
case it wants to
changing
get
the
in
axle
there.
to the vertical of the press so that when we apply pressure on it, if it was to jump out, that it's not going to pick up my ribs. See this, we're going to start.
We actually broke this loose earlier,
We
half
did
an hour
really
ago.
close,
We actually got it to break loose, and it took about 16 tons of pressure to get that perch bolt to start moving in the axle. Oops. This is the fast one, by the way, the fast cylinder, kind of slow. Okay, we're coming on.
With milling, thank you. We could set it up in a mill and we could do a end cutter and actually mill through it and get the or drill it out and maybe the heat from drilling it would create enough
Okay, looks safe.
differential temperature that it would press out. But I'm getting nervous here.
It doesn't look too safe. That isn't working too well. I need to get under that boss. Just a second. We're going to reset this. It's starting to roll.
We're going to close up the supports a little bit here.
And I don't
Taking the
like the way
pressure
that's
off.
looking.
It started tipping sideways as I was pressing on it, and it looked like it was going to shoot out. And if Pete wouldn't have been there standing in its direction, I probably would have kept going, but
I thank you.
okay.
That axle, the top and the bottom are wrong, which is why that thing was rolling, right? They're not.
Okay, we've reset.
Here
We
we
previously set up and it
reset again, and
seemed
you'll
too
see
safe. So
that
we've reset so that we have support underneath the boss.
You'll see that here the
So
boss
that we,
more closely
so it
supported.
doesn't roll on us. These surfaces are not flat on the axle, so but the bosses are. So we're gonna try this pressing this way.
I had a
We have
beautiful
a safety chain here, just in case it gets away from us, so that it doesn't take out any ribs. Okay, we're up.
There it is. And boy, when it
We're
pops, it
up to
pops.
about 5 tons.
Here we go.
And,
We get to that 16 tons and it popped.
Violently.
One of these.
that's the limit of my press travel. I'll have to reset.
Rounded surface on the bottom, that I think you could get on that and press on that.
Yeah, but what do you put down here on your press to kind of, it's all kind of weird stuff up there, you know, the little.
Well, yeah, you probably have to
Figure it
use
out.
that, you probably have to use the unsafe method.
Yeah.
See, that's where we're finished with that.
Okay, here at the, okay, we've reset. We are going to be doing our first press to straighten this axle.
Okay, we're talking about,
We're going to be
start doing a,
straightening between two marks that I made
Showing
on the
the-
table
the area that we're gonna press. Notice I have an X underneath the,
and then we're going to be
underneath the
pressing
ram,
between
and
this point
arrows
and
marked
the
out.
perch boss. We're going to be
Show where I want to
between
support
those
it,
two.
so
That's
that I
the
can
worst
create a
area.
correction in that area of the axle. So we'll be laying it down in there now, so there's a real part of
Get
it.
away from us. Take out
Very,
some of these ribs that
very,
we
very
mine.
durable metal.
And then I'm
And
gonna
of course, the
center
base on the ram is also very
the,
hard metal, and I was a little bit nervous about
point
that
I had identified as
sliding off
center.
because of the flex.
Now, the axle itself is
Softer
hardened.
metal, and I'm gonna put that between the two pieces.
The
so
ram
that,
is hardened. I
so that
want
it
a piece of
doesn't
soft
slip
metal between the two so that they don't slide, so it doesn't get out of control. So I'm just gonna put a thin piece of softer metal
Stick
between.
it between there so that they.
And I have the
So I get a little bite
axle
on both
centered
pieces.
underneath the ram. So we're ready to go here.
Now, watch how much that axle
Now,
bends.
you're gonna be surprised
Watch how
at
much.
how
it
much,
bends.
I don't like that setup on the other side. Excuse me, I'm gonna change this.
He pointed that out.
The support underneath that boss.
Not being under that boss.
Okay, we're gonna do this again. Okay. Now, you're gonna be surprised how much you see
Everything's flex.
this axle bend.
Let's just go ahead. There it goes.
And it won't take much pressure to create a pretty good bend in that axle, and it springs back a lot.
Actually, in the end, I think it
You can
shows.
see, can you see how much that's bent already? Okay, let's go a little further. And
Yeah,
we'll
see
let
those
this
metal
off.
frames they put there? That was a mistake. I shouldn't have done that. I pushed it
Okay,
too
I'm
far.
gonna sight this
I had to go back and
and get a
correct.
feeling for what that did.
Now,
Get a little bit more.
Maybe you'll get to this, but when you first start out.
Okay, that did a correction. Not a lot. I think it still needs a little bit more to go, but I don't wanna overbend it either, so
that's
we're
what
gonna take
looking
it
at
back
the
to the table and check it.
looking at the
But
light.
that's the process
Because when you're
of
done,
straightening an axle.
that
You
axle
go at the
should lay
worst
flat on
area
that table.
first,
If it's
and
perfect,
then you make
just
minor
lay flat on that
corrections
table,
all along the way
behind the
till
joints
you get
and
that
light.
axle to lay flat on that table and not see any light under it. So that will meet you at the next table.
It's just by guess and by
Yeah, okay.
judgment.
And Phil, if you look at the axle he's got up front there, you can see some of his marks on there. You'd mark. I can see where it's been from here to here. Yeah, you know, this is kind of a swale, and he marked those spots and put arrows on it. This is press number 1. So when you put it on the press, you could see roughly where you wanted to set stuff.
Yeah.
Yeah, if you look at this, you'll see like I have press number 4, and then the limit of press number 4 is from here to here. And then I have press number 5, the limits of that were from here to here, and of course, probably there may be no, there are X's on this side, so I think I did,
But when I finished with it, I think I did 6 presses on this.
On that one.
In 6 spots, but we did a few times to increase the corrections. We might have done
You
9.
got there on the press, what's on the table here now?
Yes,
Oh, okay.
yes. Well, yeah, no, that is.
Okay.
Yeah, because we took the other one into
Back
the
and
other.
forth, I mean, that's playing with the camera.
Yeah,
Yeah, we
And see
were
this-
kind of
it's
a
like.
little sleight of
what's the
sleight of
purpose?
hand with the axles a little bit, but yeah. But I think this one took about.
Okay, we went back to the table and we checked it, and that last press did a pretty
Now we're
good job
talking
of straightening
about that I
the majority
screwed
of
up.
the
I'm gonna go back. and-
flex in or the bend in the
Press it
axle,
in
but
the
we do
opposite
note that our
direction.
next area of press would be from about this point to this point. We'll want to press right here on the boss. Now, I've marked this number 2.
Oh, Pete, this is where this thing slowed down to slow motion.
Okay.
Let's go ahead and scrap the rest of this one, it's just showing the correction.
Okay, I just made that last correction.
You'll see my
And
finger.
I overcorrected. I have to go back and fix what I just did. I pressed too far. I took about 1/8 of an inch too far.
Yeah, that was good camera work.
Go right back to that same spot on the opposite side, and I'm going to press.
So I'm showing this might be the bit that I'm marking out,
before,
press number,
and we're gonna call this correction number 3.
yeah, I can probably press, right that press over there.
Now, more light is showing up probably over here.
That's where the bridge.
And
That's
you
correct.
may think the correction should be over here, but actually.
That's correct, I'm looking at, what's going to, I'm predicting, we're trying to predict what's going to happen
Is holding it up.
when I press on the certain.
So I think if we get this
Pressing
down to where it's supposed to
there,
be.
pressing right
this is
here,
gonna go
because this is so
back to the
stiff,
breast.
here will actually make the correction here, out here, if I support it out far enough.
Dave,
Okay, here we are, back to do our third press, fixing what I messed up. The last time, Pete noted that the space between the top of this axle and this hole,
Very
pretty
good
much
quality
close almost to lining up.
in my,
So, Pete, I'm gonna ask you to kind of stand back there and tell me when you think
I
we're
did
about
check.
halfway there, and maybe we can get halfway back.
It's very close,
Pretty close?
pretty close. Try
Check it. Okay.
What did I do?
We're gonna check this now.
I'm out.
I'm out.
No,
Oh, there we go.
I didn't do anything.
Okay, we just showed that press or that correction. We'll move on to the next one.
Okay, press number 3 did what we needed to do.
We're talking about
We're
press
now
number
basically
3.
straight across the ends of the axle. We do
And
have one
again, we're just making
gradual
another correction in another spot.
from
Now,
here to here.
this is kind of
Do
tedious.
a light
It's
press
got
in
this
this area
property
to try and get that straight.
tedious
And
in the
then
video.
we're close to good on this axle.
So, we're just making advances. So I'm gonna move to that, so we can kind of see.
Now, this is a pretty long press, so we're gonna see quite a bit of bowing of the axle. We don't have to move that much, so I want to be careful not to overcorrect.
Axel been all
If we've done a different axle, I kind of know how much I have to bend it to get what we need. We're gonna check.
I mean, you could set up indicators on them and measure the deflection, and then look at the rebound, and you probably could, you know,
Go back to
figure
the
out
table,
where you
we're
need
gonna
to
check
be. But it's probably way more complicated than it would ever need to be.
Does that fatigue the metal at all, the pressing?
You know, we're not moving it that much. I don't think it would. And we are cold pressing. All these corrections are supposed to be made with, cold. We're not supposed to heat it up. We did cheat a little bit when we were nervous about that, about pressing that pin out. We took 2 propane torches, not acetylene, and we actually heated the boss for a little bit while it was under pressure, probably for about 2 minutes. There was no color change or anything. Actually, we did it until the oil boiled. Till we could start seeing the oil, that we had some penetrant on there, when we could see that actually when it, probably 30 seconds past when it caught fire. And then we pressed a little more and it popped.
I forget where I've seen this, but Ford they brag about how strong their axles were, and they did a test where they mounted it and twisted it, and they got something like 5 full turns before it broke.
I don't even know that it broke.
Yeah, I don't think it did.
Twisted it that way before it broke.
Yeah, I have a little comment I'll make on that later in the video.
Dave? Ask this of the group, has anybody ever heard of a front axle braking in use on a Model A?
I've never seen one.
On the Waltons?
Oh, really?
They had a 29 AA express truck. And he hit a chuck hole and supposedly broke the front axle.
Okay, the Waltons, the double A broke the axle. Okay.
Made for TV.
Okay, our pressing process.
Okay, here we're gonna set up the, here we're talking about, the setup that we have right here now. And what I'm talking about is,
At this point now, we're gonna
is I
evaluate the
originally
axle
turned,
for twist.
four
and
of
also
these,
for, overall,
I guess I would
condition
call them adapters or the lower parts of the indicators.
and
And I turned
spring perch
the,
holes to see if
the
they're
perch,
worn and make sure sure that they're all accurate.
diameter to equal the, the diameter of
I
a,
made
First
some,
and when I went to insert it into the hole, I couldn't get it. So it was hanging up, and actually I kind of tapped it in there with a brass hammer. And I rounded up good.
Basically just
I
turn
did,
down
it
the
was pretty beat up.
OT of
So I turned another one, and I went and I
to equal
measured
the
dimensions.
size of a
That's why I
kingpin.
said that sounds like the nominal size of something.
I measured the
I did
unworn area
exactly
of a
11/16.
kingpin, and I matched
So I took
that
an 11/16
diameter
inch drill
of
bit
the,
and just took out
piece
the
of,
little
metal
words that
shaft,
turned up
and
inside
that
there,
those fit,
both locations, and then they slip in.
5/16
And when I made these,
that fits into
one
the
side is standard,
and
and the other side
so the
is.
outer holes
In case
just
one of
need to
these
be
was a
cleaned
bit,
up to
I guess
kingpin
I
diameter,
say the
and to
word
do
wallowed
that,
out.
I don't have a
you could
drill
probably
that
pick
would
up
be
an
that
indicator
precise,
that's
but I
better.
do have
One of
an
these holes
expensive bushing reamer,
is,
which would be
got
the
a mark.
exact
One of these
size
holes
of
is a
that
little bit welded
kingpin.
out, so when this is put
So
back together, you're gonna
carefully,
have to
I
put
put this through here because I
some
don't
thread
wanna
lock or some
destroy
type of,
an expensive
some
tool,
type
but
of
I
a hard,
carefully fed it through here, and I took out
I call a thread lock,
the
or what they
burr
call a
on one side that was stopping
cylinder setting from in there with that hole.
tooling or
Let that
measuring
harden up good,
device
so that, you don't
going
have a
into
loose
it.
connection here.
The other side was
Now,
clear, so it only had to clear
here,
one.
I didn't have a drill bit
I
that
discovered,
size, but,
on,
I mean, that's the exact size,
spring
of
perch
the
bolt,
actual spindle hole.
that it is
Well, I've
11/16
had a
of an
spindle,
inch.
I have a
It's
spindle bushing reamer, which is the size of this window.
6.5,
So I carefully, this is,
and that is
I
11/16.
carefully passed
I
that
just used
through.
a good
Just
sharp
to
11/16
knock off
inch drill
little,
bit, and I ran it through there to remove
metal,
burrs. And
shards
these
that were
were
in there from
burred to the
something.
point where I could not,
And then once I did that, now
I
this
did not
is,
get
in the standard size.
measuring devices into
Very
it.
nice. So they have very little
They're
movement
cleaned up
this
now.
way
I
or
did
that
that
way.
prior to setting up here. Now, what we're doing with this axle is we're gonna be checking the angles
This
of
is
the
let's see.
bolt holes to make sure that they're in alignment with each other and that
The
they are
perch bolt is
at the proper
0.6865,
camber,
and
from
then
a
the
flat
kingpin is
surface.
0.8095.
Right now, we have this axle shimmed up so
So,
that
you know, the difference, I had to make a
so
difference.
that
And
this
again,
point and this point are the same distance from the table. It just turns out that they are exactly 6 inches.
adapters,
And
standard
so that
size,
gives
and
us
then about 3,000 over
a
on
level
the other side.
in
So
relation
you
to the
did have
table
one
surface,
that you could get a good
point of
indication.
reference.
Because it's important when you're,
And,
when you're checking to see if this axle is in the
lining
line
off the end with a,
and not twisted,
with a
you're relying on the fit
square.
of those, metal location and things are straight.
Indicating
Having the Gerold
devices are placed in the holes.
Could have made it in one piece.
Yeah,
Well, I'm cheap.
yeah.
And, you know, that, this is way cheaper than that.
Even with careful
Plus, you know,
machining,
it breaks down in stores.
there is a
Higher.
little bit, I'm gonna call it slop.
And,
There's a little bit of
now,
space in here.
I think I
I
probably talked about
believe,
this
now the kingpins are really good, but
in the video here, what I'm gonna show you is,
perch
it's
holes,
very important
one is good, the other one is a little bit
and that they match.
wobbly. This is
So
going
I took and I measured
Now, I
center
would
to
say that when
center.
that radius arm is
Came up
attached
with
to
7
this
1/4
portion of the
inches.
axle and then
Exactly.
the
Center to
perch
center.
bolt is tightened in there,
Here, and you do.
probably
the
should
same
use some
thing, and it
Loctite,
is
a
exactly
good Loctite,
7
good
1/4
strong
also. Same with
Loctite,
both sides.
in between the perch
So
bolt
that's good,
the,
and then I also, it's also
and the axle,
that
just
this
to
be
take
the
up
correct
that,
angle, that's would be your
that slot.
camber
I don't
angle.
know if you can tighten
Well, I was
this
trying to
to properly
figure out how to
eliminate
measure that,
some,
and I happen to have these little gauge
good,
wedges or
thread lock or a sleeve setting
high precision
would do wonders in there.
setup tooling.
Okay, now what we're,
One is a
what
5-degree wedge
what
and
we're
one
after here
3-degree wedge.
is we wanna first of
When I
all
first
check
was on the flat
that
surface,
we have
let me back up and say that what I
distance
did is
between these,
I made sure that this axle
so that these are in
is
alignment.
parallel with the table.
And I am measuring
The table doesn't have to be level,
7 1/4
and
inches
the axle has
center
to
to
be
center.
parallel with it in relation to the distance
That's
from
exactly what I have here.
down to
So
the
these
table
two
surface.
are in
And when we
alignment.
had this all set up, the
Move to
device
this
that I
side.
had here with a distance, a set
We
distance
have
off
the
the table,
same
it was
exact
exactly
7
6
1/4
inches on both sides. Is what the setup was. So I knew that it was parallel with the table surface, and the table
And
surface
here
was
we
pretty
are
flat.
slightly greater
So I
on
took
the
these
top.
gauge,
Why? I'm a
um,
little wallowed out.
setup,
The
edges,
measuring
and
device,
I put the
being at an angle, is
my
leaning
square on top of
in the
that, and I
slop. So when you
eyeballed
bring
it
that
along
back to
the edge,
center,
and I came
in
up to
the,
exactly 8 degrees.
slop in the hole.
Every
Let's see
location.
what if I've got the same.
Now, Phil handed me an article that he
Exact,
saw that
same
in
7¼ inches.
national
center,
publication
bring it
that
back to
that
the
was
center
stated to be
point
7
of
degrees.
the slop.
Now, they also stated
They
that
are
something
in
else was
perfect
off,
alignment with
sometimes
each
2.5, sometimes
Now,
3.5 degrees. So
measuring
it was,
the camber,
I think that,
which is
how
the
did they say it was
angle,
total, well, there was
the
2.5
horizontal
degrees
surface.
on the,
I have a
on
couple
the
of degree
tip of the
triangles
spindle
here.
on the
One is
actual,
5
the
and the
spindle.
other is 3.
on the actual spindle.
And I place that on the table. And then I can take
Seven
a
on
square,
the- And then another
bring that up,
on the spindle,
and sight that.
hand.
This way.
and then I saw another article that was seven again. For this.
I am exactly
Two for the spindle,
at 8 degrees.
over 9.
Right.
Okay, let's move over and check this other one.
Well, given that this is so centered, I don't think that it could be bent to where there would be, combined, an accuracy where they would both match side to side.
Right on. Exactly.
Unless
8
it was
degrees.
down in the center,
So,
but I don't see how it could be.
Again, it should be. One is, we measured the distances between. If one is, the other is. So that's right on. Now get over to this other one.
Now, on this side, whichever side has the loose, side here, this is the one here.
Sure that this is.
That's exactly 7¼ center to center.
accurate.
And I measured this one, it's a little wider
We
here.
are right
But
on.
that's that wallowed out hole. And if I split the distance, if this thing moves
And here we are.
on the extreme,
Just a little bit off.
stop, when I get it centered on that, it's exactly 7¼ So it's just,
Okay,
it's just.
we're right on.
So it is straight. Of course, when we
I
put
have some
some
spacer blocks underneath.
very
this.
expensive wedge blocks under here to make sure that it stayed accurate. while we were measuring.
Okay, I am back at 6.
No, this is the one that was,
Okay,
that did not
I
have
take
any.
this to center point between the slot and
This
the
one was
hole.
much better to start with.
We're dead on.
Much straighter to
So
start
8
with. So
degrees
we,
is what I measure the camber
no,
to
this would
be,
be a better
and they're
thing
equal on both sides.
for your,
So
plus,
that's,
this one
that's
is
that
absolutely-
evaluation. We're good at that point. Now, I'm gonna rotate this, I'm gonna take these out, we no longer
For the
get
other
this
one,
level.
pretty deep
And
warning.
I'm gonna turn
Both
this,
sides, and
maybe
being
can
that you're doing this vehicle,
zoom the screen a little bit. Now, we're gonna check the axle
that's why we chose.
twist.
this one.
And what we're
Now, I'm
hoping,
talking
or I'm
about
hoping you
the
can see
alignment.
this, is sight
And if
down the
you guys
tips
come up here and kind
of
of take a
the,
look, you'll see that this is
of the indicators.
go halfway between the extremes.
We are pretty
You'll see
good.
that they all line up just about perfect.
This one here has a
So
little
this is
bit of
good.
movement in. If I
Little
take
bit.
it halfway between the,
I'm talking about
take it
that.
half between there.
And I think
Right on.
that the camera as best as
So
we.
this hole is just, maybe this adapter's machined a little bit undersized, I'm not sure. Let me check.
Okay, well, I think we're gonna jump to the,
Yeah,
Just
about
showing
three
that I
thousandths
measured that.
undersized.
measured and matched it up with the poles.
Okay, we're gonna
Now,
go over
we're
to the shop.
jumping to another part of the
And
shop.
we're going to
And
show you the
if
setup.
this-
that
if
you
these
use to take
were
the,
out of
twist on an
alignment,
axle. And the twist would have been identified in the previous.
especially if there were
clip.
two in a row
Would
that
have
were
been
out
that
of
alignment,
alignment.
that alignment down the
Exactly.
tips of those indicators.
So I built a jig
So I have
Well, the
fabricated
welding-
out of some heavy angle,
made up out of heavy
Some,
anchor,
a
and I
jig,
bolted it down to
bolted
the
down to my
table.
welding table.
And I can take
that will
that,
allow me
you take
to,
that, those angler,
straighten
and I
the
can
twist out of an axle,
move
I
to
can
the
mount
other
the
side
jig
of
on
the
this
table,
side of
and
the
I can
table,
move
or I can go to
friction
the other side of the
in
table.
a
depending on
different
which
direction.
side of center line that I need to do the
I
straightening.
really can
I
only
may have to do a little
safely,
straightening between here. Would be
apply
extreme,
pressure to
but
the
typically
table
it's
in the
across
wrong
the whole
direction.
axle that
And
you
just
need
line
to
it up
make the correction for a
when I set
twist.
this up.
So,
We're
this
gonna-
fits into this area, and you can position it wherever you need it, wherever you need to make it. You
I
can
have
do a short
great
correction,
5 volts,
which would
5
be
18
extremely hard to do,
volts,
or a longer correction. Let's just assume that we need to straighten
setting it
from
up.
about
This year,
here over.
I wanted to
We're gonna
make
try and do the correction
part of
someplace
the-
in this part of the axle.
And we
Some bolts
do grade 8 bolts.
that get entered
And
into
we
it to secure it. This angle is already locked down side, so I'm gonna reverse the bolts. So I can lock this side down.
Not fully up against the slide.
I used grade 5 bolts
We have a,
to fasten the angles down, and then these are grade 8.
remolding it,
These
and then,
these grade 8 ones have to hold quite a bit of
it's done.
force in the setup.
And then, wrap it around.
All this time.
Yeah. Literally.
Okay, that is pretty well done. Now I'm going to pull this side down.
Why don't you put fire? Well, and then it's about the top.
Okay, I think I have a little too much tension on these. I want to make sure this is pulled on tight. Okay, that's not all the way, but it's pretty good. I'm satisfied. Okay, now that is securely held to the table. And what we're going to be doing is going to use a large wrench to execute this correction. You want to make sure you get across the entire entire height of the axles. You want to set deep enough so that you're exerting the forces both on the top part of the I-beam, top part and the lower part. And you're going to be creating a twist. Now, I'm not going to put the force on this because this axle is actually pretty straight. But I'm just showing you the setup that you'd have to do if you needed to straighten the twist out. And you're going to need to put a long pipe on this, and if you have a larger wrench than this, I suggest that you would use it. This is the largest one that I have at my shop, and I would put another pipe on this and I would pull down on it to get that twist. Now, I saw a video on YouTube where a guy had an axle set up on the end of a front-end loader with pallet forks on it, and he had secured that axle to these front forks.
And he
And he had a wrench. That thing was 4 feet long. And then he put a 4 or 5 foot pipe on the end of it yet. So he had about 9 feet of leverage. And he was pulling down on this axle, and he was getting to the point where he was touching the ground with the pipe. And he still hadn't gotten the correction he wanted yet. So he raised the loader up to it till it was about at his eye level, and he pushed down on it. I would say he got
down to the ground again.
I would say 60 degrees of rotation to create the correction that he wanted, because it kept springing back as he released pressure on it. He did eventually get it, but it looked dangerous. Now, the reason I mounted this up like this is because I have the table, the advantage of the weight of the table, and I'm sure that if I put too much pressure on this, that table could flip. So with a little bit of safety in mind, I'd want to do this with another person here. And
That table
just take it easy, or be careful.
twist.
This is not a safe process in my mind. So that's what you do to straighten these things. And again, all of these corrections on these axles are supposed to be done with cold press and a cold twist.
All this stuff
You're not supposed to heat them.
Well pressed and.
So that's the process of
So I think we're
straightening
gonna-
axles, and we're gonna. Okay, we said we were gonna move to the other room, but before we did that, or before we do that, Let's verify that this axle is actually straight. So we came in, we put in the measuring devices or the pins, and you can see that that axle is
No, and then
is
now
nice and
after you
straight.
do that.
Now on this particular axle, I did not clean
Twisting
the,
correction, and you would put these back.
kingpin holes. So you'll see that there is a burr here, and I don't want to force my tool in there and damage it, but I did get it in far enough that it's giving me a good indication of straightness. And the perch hole back here also has a burr that I would need to run that 11/16 inch drill through so I could get it fully to see. But I am far enough again into it that I can tell that, that the indicator is in line with the axle. So it's straight. I think you can see that, that the rods line up with each other.
It was done
So
out.
we are good. This
Vinyl
axle will be
shed
ready
on the
to,
grass next to,
ready
under.
to finish up.
It wasn't highly technical. I just watched the force that he put on this thing to make a correction. It was.
I can understand how the axle like that would get the bends and that you did correct, but how it would get twisted is hard to imagine. Because you'd have to really hit something, get that kind of leverage on to twist that.
I know. Yeah,
What?
I wouldn't see how they would be twisted that much either.
I think the Ford pickup trucks in the seventies, eighties and nineties had that, they called it the, and in the Ford dealership or in the alignment shops, they bent them in place somehow. To straighten them.
Yep.
Could you do the same thing like that?
In place.
Huh?
In.
Well,
the
the
height
same
of-
equipment or it's alignment shop?
That's the only way you can change the camera on a PMAX.
Before you put pushing.
Like in a truck shop?
Yes.
So Mark, again, your question is, could you,
Could you, and all the hard work you're doing there, could you take it to an alignment shop?
well, I'm sure they would do the same thing that I'm doing.
twist. No tools, don't twist. They don't twist? All they do is just bend your camera angle.
They would probably
I've
bend
done a bunch of them.
in between here, right, from this point and that point,
Okay.
to change your camera.
So Dave, let me interrupt here and ask, the setup you've got on the screen, with these rods, you could be twisting and immediately see the result.
You could see the correction. You'd have to take the weight off of it and see the correction.
And it'd be like right out.
Yeah.
Okay.
Probably have to twist it 3 times as far as you really want to correct. That's what.
Yeah.
That's why, yes.
Well, I mean, this guy was bending, he had to have been twisting that axle 60 degrees based on eye height down to 0, about, 9 feet out. I think that's about 60 degrees in my head. I think we have one more. Yeah.
Okay, this should be the last segment of our axle straightening video here.
I think
Just wanted to show you the tools that we're actually, again, recap the tools that we're using to do this. First of all, we have a kingpin bushing reamer to take any burrs out of the ends of the axles. We also have a 11/16 inch
Yeah, you want to?
drill. Okay, we said we were gonna move to the other room, but before we did that, or before we do that, let's verify that this axle.
You just took a picture.
Oh.
There you go. You're not sharing anymore. Good.
Okay, yeah, 11/16 on the perch holes, and then whatever the kingpins I measured with, not a micrometer, with a caliper, I measured 0.8095 is what I measured.
Yeah, not quite.
That's 13/16, isn't it?
Yeah, it's
Yeah.
a little bit under.
Is it? Okay. I didn't put a drill bit down it because I had the reamer, and I knew that was exact size. So,
13 is 0.812.
okay. So any other questions? That's kind of the study on it all.
Very cool.
I was just wondering, so this is, working on, a part that's been in operation for 60, 70 years. But I'm wondering, back when it was manufactured, what they went through, I mean, they would have had, I'm sure there's tolerances, but when they manufacture it, they probably have a, setup where they measure it, make sure that it's within tolerance, and then they go on to the next one, but they're making thousands of these.
you know, obviously this is a forging. You know, it would have been forged, so all of these surfaces would have been there, you can actually see you can see the break on the die for the forge here, right across the top of the axle. And then I'm sure they had a dedicated machine that had the 7 or 8 degree angle here, and it came down. It drilled the hole, it probably surfaced the edge, it probably came up and surfaced from the bottom side. Into the edge. It was an automated machine that just probably did this all in one. You know, just put some drilling tools on it.
And if they were off a little on the shape of the axle, as long as those 4 holes are in line with each other, they could have a big dip in that axle.
That's exactly right. That axle could go down to a V as long as these were in the right location and at the right angle. That car would work just as good as if the axle is shaped as it is now. It's kind of important, I suppose, to get your car going straight, but it's not real technical as far as doing the work. You can kind of see it with just kind of eyeballing it across a flat table. And that's all it took to get this axle really good. I think this one started out, probably, it probably had a 1/4 inch. I was probably seeing a 1/4 inch of light on it when we put it in place. The other one that we did, that we were kind of interchanging in some of the videos, so that one had up to 3/8 of an inch out of whack.
Yeah, I probably got bent in the middle for somebody jerking on a chain to pull it out of the something.
It was definitely crowned forward, but it had one spot about like right here that had a kink in it that came backwards. They hit something hard from front on, and then the rest of it was just from probably pulling out with chains or being towed out of
They probably bent it by pulling it out of the ditch and they say, oh shit, we bent the axle. So if we bang it up against the stump, we'll bend it.
It was actually, you know, now that I think about it, it was actually such a, it came to such a point that I think it almost looked like it was something metal or concrete that it hit.
Yeah.
You know, it was too sharp to be a stump would be generally a rounded bands.
10 miles an hour and hit that stump and we'll straighten right out.
Yeah. Okay, thank you.